Welcome to the channel. Please consider subscribing. I produce videos covering AWS, Azure, and GCP on a daily basis. Please also hit the bell button to get notified. Welcome to our comprehensive guide on Google Cloud's next-generation firewall. This presentation will take you through the revolutionary changes Google has introduced to network security in GCP. We're looking at 4 major innovations. IAM governed security through secure tags, organization-wide policies that span multiple VPCs, Layer 7 inspection with deep packet analysis, and micro-segmentation capabilities that provide granular control down to individual virtual machines. This represents a fundamental shift from traditional network security approaches. Instead of managing individual firewall rules per VPC, we now have enterprise-grade security policies that can be applied consistently across an entire organization's cloud infrastructure. Architectural revolution. Let me walk you through this architecture diagram that shows the fundamental difference between legacy and next-generation approaches. On the left, we see the traditional model where each VPC network has its own set of individual firewall rules, and network tags are simple strings without any governance. On the right, the next-generation model shows a hierarchical approach. At the organization level, we create firewall policies that can be applied to multiple VPC networks simultaneously. These policies leverage secure tags that are governed by IAM, providing enterprise-grade access control. The table below the diagram highlights the key differences. Notice how we've moved from single VPC scope to organization-wide policies, from individual rule management to policy-based approaches, and from simple network tags to IAM-governed secure tags with full audit trails. Understanding secure tags architecture. This diagram illustrates the hierarchical structure of secure tags and how they enable sophisticated virtual machine classification. At the organization level, we create tag keys that define categories like virtual machine function and environment. Under each tag key, we create specific tag values. For example, under virtual machine function, we might have web server, database, and load balancer. Under environment, we could have production, staging, and development. The powerful part is that each virtual machine can have multiple tags applied to it. Virtual machine 1 might be both a web server and production, giving it multiple dimensions of classification. This enables incredibly granular firewall rules based on both function and environment. The comparison boxes show why this is revolutionary. Traditional network tags had no IAM control and could be modified by anyone with virtual machine access, while secure tags are protected by strict IAM governance. Secure tags components deep dive. This table breaks down the 4 essential components of secure tags. The tag key defines your category. It must have the purpose set to GCP firewall to be used in firewall rules. Examples include VM function or environment. Tag values are the specific classifications within each category. They must be unique within their tag key. Examples would be web server under VM function or production under environment. Purpose data is critical. It scopes the tag to a specific network or organization, providing an additional security boundary. This ensures tags created for one network can't accidentally be used in another. Bindings are how we attach tag values to actual resources like virtual machine instances. The rule is 1 value per tag key per resource, so you can't have a virtual machine that's both web server and database under the same tag key. The IAM roles shown below are essential. Tag admin for creating and managing the tag taxonomy, tag user for actually applying tags to resources, and custom roles for very specific permissions. Creating secure tags. Command analysis. Let's break down each command shown on the slide. The first command, G-Cloud Resource Manager tags keys create VM function, creates a new tag key called VM function. The parent parameter specifies this is created at the organization level with ID. The purpose parameter is crucial. It must be set to GCP firewall for firewall use. The purpose data parameter scopes this tag to only work within the specified VPC network, adding an extra security layer. The second command creates a tag value web server under our VM function key. Notice how the parent parameter references the full path to the tag key we just created. The third command creates another tag value database under the same key. This establishes our taxonomy where virtual machines can be classified as either web servers or database servers. The fourth and fifth commands create an entirely separate tag key called environment with a value production. This demonstrates how you can create multiple classification dimensions for comprehensive VM categorization. IAM governance and tag binding commands. The first command G-Cloud organizations add IAM policy binding grants the tag admin role to admin@company.com at the organization level. This allows them to create and manage all tag keys and values for the entire organization. The second command is more granular. It grants tag user role specifically for the VM function tag key to developer at company.com. This person can bind values from this tag key to resources but cannot create new keys or values. The third command G-Cloud Resource Manager tags bindings create actually attaches the web server tag value to a specific VM instance. Notice the parent parameter uses the full resource path, including the compute API, project, zone, and instance name. The fourth command shows how to apply a second tag to the same versus M in this case, marking it as production. This demonstrates multi-dimensional tagging where a single VM can have multiple tag classifications. The key benefit highlighted is that this creates centralized management with audit trails, strict access controls, and automatic inheritance down the organization hierarchy. Legacy VPC firewall commands analysis. Let's examine these traditional firewall commands. The first command G-Cloud compute firewall rules create web allow HTTP creates a basic firewall rule. The action parameter is set to allow, and direction to ingress for incoming traffic. The network parameter specifies which VPC this rule applies to. Notice it's limited to a single VPC. The priority parameter of 1000 determines the order of rule evaluation, with lower numbers having higher priority. The allow parameter specifies the protocols and ports, in this case TCP 80 and TCP 443 for HTTP/HTTPS. The source ranges of quad 0/0 means traffic from anywhere on the Internet, and target tags specifies which virtual machines this rule applies to based on their network tags. The second command shows service account usage. Instead of network tags, it uses source service accounts and target service accounts to identify the source and target of the traffic based on service account email addresses. The third command demonstrates logging with enable logging and logging metadata set to include all, which captures comprehensive information about traffic that matches this rule. The limitations are clear. Single VPC scope, individual rule management, basic network tags only, and layer 4 filtering exclusively. Network firewall policies, new command structure. Here we see the new command structure for next-generation firewalls. The first command G-Cloud compute network firewall policies create my global policy creates a firewall policy, not just a rule. The global flag indicates this policy can be applied across multiple VPCs networks. The second command creates a rule within that policy using G-Cloud compute network firewall policies rules create 100. The priority is now the first parameter, 100. Making it more prominent since rule order is crucial in policy-based firewalls. Notice the new parameters. Layer 4 configs replaces allow, providing more structured protocol specification. The global firewall policy flag indicates this rule belongs to a global policy rather than a regional one. The third command G-Cloud compute network firewall policies associations create is entirely new. It associates the policy with a VPC network. This separation allows you to create policies once and apply them to multiple networks. The key change highlighted is the move from firewall rules to network firewall policies in the command structure, along with the new Layer 4 configs parameter and global firewall policy scope flag. Advanced rule actions and flow control. This diagram shows the sophisticated traffic flow control available in next-generation firewalls. When traffic hits a rule with priority 100, it can take one of 4 action types, not just the simple allow/deny of legacy rules. The allow and deny actions work as expected, but go to next is revolutionary. It allows traffic to continue to the next rule in the policy for further evaluation. This enables complex decision trees where multiple rules can evaluate the same traffic. The Apply Security Profile Group action routes traffic through enterprise-grade security profiles that can perform deep packet inspection, TLS decryption, and threat analysis before making a final allow/deny decision. Looking at the commands, the first G Cloud Compute Network Firewall Policies rules create 100 shows a rule with action equals go to next. This rule evaluates traffic on TCP/80 but doesn't make a final decision. It passes control to the next rule. The second command shows action equals apply security profile group with a reference to a security profile group. This routes traffic through enterprise security analysis before final disposition. Secure tags in firewall rules. Now we see secure tags in action within firewall rules. The first command, G Cloud Compute Network Firewall Policies rules create 100, creates a rule that allows web traffic, but notice the source and target specification. Instead of IP ranges or simple network tags, we use SRC secure tags and target secure tags with the full organizational path to the tag values. The source is organization/123/tag keys/VM function/tag values/load balancer and the target is organization/123/tag keys/VM function/tag values/web server. This means any virtual machine tagged as a load balancer can send HTTP/HTTPS traffic to any virtual machine tagged as a web server, regardless of their IP addresses or which VPC they're in, if properly peered. The second command creates a rule allowing database connections from web servers to database servers. Again, this is based on the virtual machine's secure tag classification, not their network location. The dynamic security benefit is crucial. When you add or remove tags from virtual machines, the firewall rules automatically adapt. You never need to modify the firewall rules themselves as your infrastructure changes. Cloud NGFW Enterprise Architecture. This diagram illustrates the Cloud NGFW Enterprise Architecture. At the organization level, we create a firewall endpoint using the G Cloud Network Security Firewall Endpoints Create My Endpoint command. This endpoint is associated with a specific zone and requires a billing project. The firewall endpoint provides the compute resources for enterprise features like intrusion prevention, TLS inspection, threat intelligence, and Layer 7 filtering. These features require dedicated processing power, which is why they are implemented as managed services. The second command G Cloud Network Security Firewall Endpoint Associations Create connects the endpoint to your VPC network. This is where the traffic actually gets inspected by the enterprise features. Notice how the endpoint association specifies both the endpoint with its full organizational path and the network with its full project path. The zone parameter ensures the endpoint is in the right location for optimal performance. The enterprise features shown, IPs, TLS inspection, threat intelligence, and Layer 7 filtering, are all services that run on these firewall endpoints, providing capabilities that were previously only available in expensive hardware appliances. Security profiles and TLS inspection. The first command G Cloud Network Security Profiles Threat Prevention Create My Threat Profile creates a threat prevention profile at the organization level. This profile contains the configuration for detecting and blocking malicious traffic patterns. The organization parameter specifies this is organization-wide, and location equals global means it can be used across all regions. The threat prevention profile analyzes traffic for known attack signatures and suspicious patterns. The second command G Cloud Network Security profile groups create my profile group bundles security profiles together. The threat prevention profile parameter references the profile we just created using its full organizational path. Security profile groups are important because firewall rules reference these groups, not individual profiles. This allows you to update security configurations without modifying firewall rules. The third command G Cloud Network Security TLS inspection policies create my TLS policy sets up TLS inspection. The CA pool parameter references a certificate authority pool that contains the certificates needed to decrypt TLS traffic. TLS inspection works by decrypting traffic at the firewall, inspecting it for threats, then re-encrypting it for delivery. This provides security for encrypted traffic while maintaining end-to-end encryption principles. FQDN objects and address groups. The first command G Cloud Compute Network Firewall Policies FQDN objects create Google APIs creates an FQDN fully qualified domain name object. The FQDNS parameter accepts multiple domain patterns including wildcards like star.googleapi.com and star.google.com. FQDN objects are powerful because they automatically resolve to current IP addresses. As Google's IP ranges change, your firewall rules automatically adapt without any manual updates. The second command G Cloud Compute Network Firewall Policies address groups create internal ranges creates an address group containing multiple IP ranges. The addresses parameter accepts CIDR notation for private IP space. The third command shows how to use the FQDN object in a firewall rule. The dest FQDN parameter references the FQDN object we created, and the rule allows HTTPS traffic to any IP address that resolves from those domain names. The fourth command demonstrates using the address group as a source. The SRC address groups parameter references our internal ranges group, allowing you to manage IP ranges centrally and reference them in multiple rules. The benefits are significant. Dynamic IP resolution keeps rules current automatically. Centralized address management reduces errors, and automatic updates adapt to infrastructure changes without manual intervention. Command structure evolution. This comparison table shows the fundamental evolution in command structure. The command base row shows we've moved from G Cloud Compute Firewall rules to G Cloud Compute Network Firewall policies. This isn't just a name change. It reflects the shift from individual rules to policy-based management. For scope, legacy commands used network equal VPC name to limit rules to a single VPC, while next-gen uses global firewall policy to enable organization-wide application. Protocol specification changed from allow equal TCP:80 to layer 4 configs equal TCP:80. This new format is more structured and supports additional protocol features available in next-gen firewalls. Tags evolved from simple target tags equal web to the full organizational path target secure tags equal org/key/value. This change enables IAM governance and cross-VPC functionality. Actions expanded from basic allow deny to include go to next for rule chaining and apply security profile group for enterprise security analysis. The advanced row shows the biggest difference. Legacy firewalls were limited to basic layer 4 filtering, while next-gen supports FQDN objects, geolocation filtering, and threat intelligence integration. The comparison boxes summarize this perfectly. Legacy approach was individual rules with single VPC scope and basic layer 4 filtering, while next-gen is policy-based, organization-wide, with layer 7 capabilities and enterprise features. Revolutionary Capabilities Overview. Let me walk through these 8 revolutionary capabilities that make next-generation firewall a game-changer. Hierarchical policies allow you to create consistent security policies that apply across multiple VPC networks and even your entire organization, eliminating the need to recreate rules for each network. Layer 7 inspection goes beyond simple port and protocol filtering to analyze the actual application content, detecting threats that hide within legitimate traffic patterns. FQDN support means your firewall rules can reference domain names that automatically resolve to current IP addresses, making rules more maintainable as cloud infrastructure changes. Geolocation filtering allows you to block or allow traffic based on geographical regions, useful for compliance requirements or threat mitigation from specific countries. Threat intelligence integration automatically updates your firewall with current threat feeds, blocking known malicious IP addresses and domains without manual updates. IAM-governed tags provide enterprise-grade access control over who can create, modify, and apply security tags, with full audit trails for compliance. TLS inspection decrypts encrypted traffic for analysis while maintaining security, crucial as more threats hide within encrypted connections. Zero Trust enables micro-segmentation and principle of least privilege by default, moving from network-based to identity and function-based security models. Implementation roadmap and strategy. This roadmap diagram shows a practical approach to implementing next-generation firewall capabilities. Phase 1 focuses on secure tags, including creating your tag taxonomy, implementing IAM governance, and starting to tag new workloads. This gives you experience with the new model without disrupting existing systems. Phase 2 introduces network policies, which involves creating your first firewall policies, gradually migrating from legacy VPC rules, and implementing FQDN objects for dynamic IP management. This phase builds on your tagging foundation to create more sophisticated security policies. Phase 3 adds enterprise features, such as deploying firewall endpoints for advanced capabilities, configuring security profiles for threat prevention, and enabling TLS inspection for encrypted traffic analysis. This phase requires the most planning and investment but provides enterprise-grade security. The final goal is Zero Trust architecture, which is a comprehensive security model where every connection is authenticated, authorized, and encrypted, regardless of location. The key takeaways emphasize that this is backward compatible. Your existing VPC's rules continue working alongside new policies. You can implement gradually, gaining experience with each phase before moving to the next. Organization-level planning is crucial because many features require organization-wide permissions and policies. The enterprise ROI justifies the investment in Cloud NGFW Enterprise for organizations serious about advanced threat protection. Most importantly, this creates a future-ready foundation for zero-trust networking and micro-segmentation that will scale with your organization's security needs. Please hit the subscribe button if you haven't done so already. Thank you for your attention, and I'm excited to see how you implement these capabilities in your own environments.